Hello, today I've decided to solve multiple choice questions. Specifically, this is physical quantities, units and measurements. This is going to be part one of these videos. So this is part one. So this is part one of the solved past paper questions under physical quantities, units and measurement techniques or measurements. Remember, the unit of measurements is now taught under practical skills, so you may not have it as an independent unit, but we may find some questions about measurements or measurement techniques in this video. So without wasting time, let's start with the first question. What is needed to accurately represent all physical quantities? So these are some of the alternatives given. A is a base unit and a number. Remember, a physical quantity should have a unit. It should have a unit which is just a letter which represents the measurement. It should have a magnitude which is just a number, so it is a number which is a magnitude and a unit. So it is a number which is a magnitude and a unit. That is what expresses, or that's what is used to represent a physical quantity. So let's see the alternatives here: a base unit and a number. Of course, a number will be a magnitude and a base unit. So what is needed to actually represent physical quantities? So a base unit and a number, a unit and a number expressed in standard form that does not change anything, a unit and a numerical magnitude. Of course, numerical, that is not going to be a number. So a number is going to express magnitude. So the best way to the best answer would be a unit and a numerical magnitude. Because a numerical, that is going to be a number. So the best answer is going to be A. A voltmeter can connected across a resistor in a circuit reads 3.6 volts. What could be the current in the resistor and the resistance of the resistor? So by Ohm's law, V is equal to I times R. So if V is equal to I times R, we shall just check, because V should be 3.6 volts. A voltmeter connected across a resistor in a circuit reads 3.6 volts. So we want V to be 3.6 volts. So we check which combination gives us 3.6 volts, because V is going to be I times R. I'll just check the last two, because I think the answer could be C or D. So let me check 1.5 milliamperes exponent negative 3, then times 0.24 mega is exponent 6. So that is 360, so that means that is not correct. Let's check D. We have 15 micro. 15 micro is exponent negative 6. And we multiply this by 240 exponent 3, that is kilo, which gives us 3.6. So our answer is going to be D. It is D which gives us 3.6. Which quantity is a vector? Remember, vector has both magnitude and direction. Momentum has magnitude and direction. Speed is a scalar quantity. Temperature is a scalar quantity. Young modulus is a scalar, so the vector is A. Which quantity is a physical quantity? A physical quantity must have a unit and a numerical magnitude. Flavor, we have seen quark flavors in particle physics. That is not a physical quantity. A Kelvin is a unit. Minute is a unit. So the physical quantity here is going to be potential difference, which is measured in volts. What is a power of 3.7 megawatts? Mega is times 10 power 6. So we want to express it in kilowatts. The easiest way is to first change it to watts. So in watts, it is 3.7 times 10 power 6. That is in watts. Then to change to kilo, kilo is 10 power 3. So to bring a prefix, we multiply by its value. To remove a prefix, we divide by its value. So this will be divided by 10 power 3. Because I'm bringing in a kilo. So to bring in a prefix, I divide by its value. So that is 3.7 exponent 6 divided by 1 exponent 3, which is 3,700. So this is 3,700 watts. When I move 3 steps to the left, it is 3.7 times 10 power 3. That is now, and power 3 is kilo, so that is 3.7. Did I miss out something here? Okay, let me check this again. So mega is 10 power 6. Then that is to remove mega, I multiply by 10 power 6. Then to bring kilo, I have to divide. So this is 3.7 times 10. Because I've divided by 10 power 3, it is already in kilo. So it is 3.7 times 10 power 3 kilowatts. So the answer is going to be C. What is the difference between a scalar quantity and a vector quantity? A scalar has only magnitude, a vector has both magnitude and direction, so it means our answer is going to be C. That is, a vector quantity has direction, but a scalar quantity does not. When you say vector quantity has magnitude, but a scalar quantity does not, both of them have magnitude. So a train of mass 600,000 kilograms moves with a speed of 100 kilometers per hour. What is the order of magnitude of the kinetic energy of the train? Kinetic energy. So what is very important here is to change the speed from kilometers per hour to meters per second. So we find the speed will be equal to 100 kilometers. I'll multiply this by 1000 to change it to meters. Divide by time is 1 hour. So 1 hour is going to be 3600 seconds. So I'll check the speed. 100 times 1000 divide by 3600, 250. 100 times 1000 divide by 3600, so that is 250. That is 27.8. 27.8 meters per second. That is the speed. So I want to find the kinetic energy. Kinetic energy is going to be equal to a half times the mass, which is 600,000, times the speed, which is 27.8, but this is squared. So the answer, I'll square that. Then times 600,000. Then divide this by 2. So this is giving me 2.3 times 10 power 368 times 10 power 8 joules. So they wanted the order. So the order here is going to be 10 power 8. So the answer is going to be B. What are the SI base units of EMF? Of course, EMF is in volts, because we know that EMF is the energy per unit charge. And energy is work done, which is energy can be work done, or any formula for energy, which can be work done, which is force times distance. I'll just use force times distance here. So energy is going to be equal to work done over EMF is equal to work done per unit charge, or energy per unit charge, which is going to be force times distance over charge. Remember, charge is IT, so I'm just going to come up with the units. Force is kilogram meters per second squared, but because times D to become kilogram meters squared per second squared, divide by Q, which is going to be IT, which is going to be amperes seconds. So our unit will therefore be kilogram meters squared per ampere, and then S power 1 goes up, it becomes S power -3. And this makes our unit to be, is it power -3? Let me check it again. Kilogram meters squared, S power -3, yes. So our answer is going to be B. Kilogram meter squared per ampere per second power -3, I mean S power -3. So which quantity is a vector quantity? Remember, vector has magnitude and direction, so our answer is automatically D. What could not be a measurement of a physical quantity? Physical quantity should be having a unit and a numerical value. We can easily see the numerical values here. We can easily see the numerical values, but we have to check the units. units if they really exist. This is 10 Kelvin, that Kelvin is the unit of temperature. Let's check this unit if it is really making any sense. So J is joules. Joules can be unit of work done, which is force times distance. So joules is the same as kilogram meters per second squared times meters. That is for energy, which is work done, force times distance, kilogram meters per second squared. Then newtons per newton. So this is over a newton, and newton is kilogram meters per second squared. Then per meter, it means meter is in the denominator. So you notice that this is cancelling out, cancelling, cancelling, cancelling. So this one is equivalent to no unit. So that one is equivalent to no unit. And if it has no unit, then it is not a physical quantity. So our answer is going to be B. You can check the rest and see if the units cancel out. So joule per newton per meter is equivalent to no unit. So it means this is not a physical quantity. A computer memory stick is labeled as having a storage capacity of 128 gigabytes. The letter B stands for byte, which is a unit. What is the equivalent storage capacity? So 128 giga is times 10 power 9 in bytes. So when I move 2 steps, it becomes 1.28 times 10 power 11 bytes. So the answer here is going to be automatically B. Which statement about scalar and vector quantities is correct? We know a scalar quantity has only magnitude, a vector quantity has both magnitude and direction. So automatically here our answer is going to be a scalar quantity has direction. That is not true. A scalar quantity has magnitude but no direction. I think that is true. The rest may not be making any sense. Which term represents a physical quantity? A physical quantity. Meter is a unit. Percentage uncertainty, that is not a physical quantity. Quark flavor, that is not a physical quantity. Spring constant, remember K, spring constant from Hooke's law is F over extension. So it has a unit. It will have a numerical value, a numerical magnitude, and a unit. So this is a physical quantity because it can be expressed with a unit and a numerical magnitude. Which two units are identical when expressed in terms of SI base units? Identical. We can check. So this is base units. This is not base. We can try to change this base units. So a joule is a unit of energy which can be work done, which can be force times distance. So the joule can be kilogram meters squared per second squared, that is for work done. A coulomb is a unit of charge, which is I times T. The coulomb is I times T. So I is amperes and then T is seconds. So this will become kilogram meters squared. A goes up, it becomes per ampere, and S goes up, it becomes S power negative 3. So they are not identical. Let's check the second one. Joule is kilogram meters squared per second squared, then times seconds. When you simplify this, it becomes kilogram meters squared per second power negative 1, which is the same as this one, which means B is correct. Which estimate is reasonable? 1 times 10 power negative 3 kilograms for the mass of a grain of sand. 1 times 10 power negative 3 kilograms for the mass of a grain of sand. So this is very small. A grain of sand can be measured easily on an electronic balance. This value is extremely small, so it is not reasonable. Then 1 times 10 power negative 2 meters cubed for the volume of a tennis ball. For the volume of a tennis ball, we can try to use it to estimate the radius and see. So for volume, if we assume the tennis ball is spherical, it means the volume is going to be 4 over 3 pi r cubed. So if I try to make r the subject, so r is going to be 3 times 1 times 10 power negative 2 divided by 4 pi under the cube root. I made r the subject, so we can check. 3 times 1 exponent negative 2 divided by 4 pi. Then we find the cube root. So this is giving us the radius as 0.13. So that is a very small radius. Okay, we can multiply it by 100, and we see we change it to meters. To centimeters. So that is 13 centimeters. There is no tennis ball which has a radius of 13 centimeters. That would be way big. So this one is also out. 1 times 10 power 0 joules, that is the same as 1 joule for the work done lifting an apple from a waist height to head height. So work done is force times distance. The work done is force times distance. The force is the weight. So we can approximate the mass of an apple to be around, I can take 50 grams. So I will say 50 times 10 power negative 3. Then times 9.81. That is the force, because the work done is going to be mg times h. Then lifting an apple from the waist height to the head height. Let me assume somebody is tall enough so that from the waist to the head height is approximately 40 centimeters. Let me say 40 centimeters. So this will be 40 times 10 power negative 2 to change it to meters. So the work done will be 50 exponent negative 3 times 9.81, that is g. Then times 40 exponent negative 2. So that is already 2 joules. That is already approximately 2 joules. So that is approximately 2 joules. And this one is saying 1 times 10 power 0 joules, that is approximately 1 joule. So if I've got 2 joules, it means that there's also a possibility of getting 1 joule if I had chosen a smaller value of the mass or a smaller value of this. So this is a reasonable estimate. What is the symbol for the SI base units of temperature? Of course, that is Kelvin. An object is moving with an initial velocity of 4 meters per second to the right. The velocity of the object changes so that its final velocity is 3 meters per second downwards, as shown in the figure here. Which arrow represents the change in the velocity of the object? So since the final velocity is only in the vertical, it means that there should be a component that cancels out the horizontal velocity. There should be a component in the horizontal to the what? There should be a component in the horizontal to the left that cancels out the component, the initial velocity to the right. So let's first check which of these diagrams have a component in the horizontal to the left. So here, this one has a component in the horizontal to the right and in the vertical downwards. So there's no component cancelling out. There's no component cancelling out the 4 meters per second to the right. So this one is out. Let's check this one. This one has a component in the horizontal pointing to the left and a component in the vertical pointing downwards. So this one could be having a component in the horizontal which cancels out that one to the right. Let's check this one. It has a component in the horizontal to the right and a component in the vertical, so this one cannot cancel out the other one. This one has a component in the horizontal to the right, to the left, and a component in the vertical upwards. But then let's look, we notice that the final velocity is downwards, which means that this one here is, because it has a component upwards, yet the final velocity is downwards, it means this one is also out. Therefore, our correct answer is going to be B, because our final velocity is downwards and there's a component, it has a component in the horizontal to the left to cancel out the 4.0 meters per second. So our answer is going to be B. Which pair of quantities are physical quantities? Remember, the physical quantities should have a unit and a numerical magnitude or a magnitude. So charge and ampere, those are units. Kilogram, that is a unit. Pascal, that is a unit. Period is time. Potential difference, so the answer is going to be D. Which list of unit prefixes describes in magnitude from left to right? Which list of unit prefixes decreases, not describes, decreases in magnitude from left to right? So remember, you should have the sizes of these values. Cent is 10 power negative 2. Dec is 10 power negative 1. Milli is 10 power negative 3. So we want which list of unit prefixes decreases. So this one is, actually this one is from cent. This one, dec is bigger, so that one is wrong. Dec is bigger, but cent is bigger than milli, that is wrong. Pico is 10 power negative 12. Kilo is 10 power 3. Milli is 10 power negative 3. So it means this is not decreasing because pico is small, so that is wrong. Automatically our answer is going to be D because kilo is 10 power 3. Milli is 10 power negative 3. Pico is 10 power negative 12. So the answer is D. The drag coefficient CD is a number with no units. It is used to compare the drag on different cars at different speeds. CD is given by this equation here, where F is the drag force on the car, rho is the density of the air, A is the cross-sectional area of the car, and V is the speed of the car. What is the value of N? So here we shall simply use homogeneity. So since CD is a number with no units, when I make 2F the subject, I'll just simply say 2F is going to be CD times V power N times rho times cross-sectional area. So I'll just equate units. So I will ignore the coefficients and the constants which have no units. So F is kilogram meters per second squared. On the other side, I have CD, which has no units, so I will ignore it. V is defined as speed, so it is going to be meters per second, but this is raised to power n. Then rho is density, so I will say times density is kilograms per meters cubed. And A is cross-sectional area, which is meters squared. So I want to find n. I'll just combine. I'll simply use m, or let me use s. If I use s, on the left-hand side I have s power negative 2. On the right-hand side I have only s power negative 1 times n, that is negative n, which means my value of n is going to be 2. And precisely the answer is going to be B. I would also use m. On the left-hand side I have m power 1. On the right-hand side I have m power n, then plus negative 3 because there's another m power negative 3 there, then plus 2 because there's another m power 2. I add the powers. So 1 is equal to n minus 3 plus 1 plus 2 is the same as minus 1, which means n is equal to 2. So what is essential when recording a measurement of a physical quantity? What is essential when recording a measurement of a physical quantity? Of course, it must be represented by a numerical magnitude, which is a number, and a unit. Therefore, our answer is going to be B. The measurement has a unit and a number. The measurement has an SI unit. It should have a number. The measurement has a unit given as a base unit. Not necessarily, it should have a unit and a number, which is a numerical value. The mobility mu of electrons traveling through a metal conductor can be calculated using the equation mu is E over m times tau, where E is the charge on an electron and m is its mass. The average time between the collisions of an electron with the atoms in the metal is tau. What are the SI base units of mu? So here, E is charge. So the units of charge are going to be, because charge is I times time, the units of E are going to be ampere seconds, M is defined as mass, whose unit is going to be kilograms, and T is time, so this is going to be times seconds. So this is going to be equal to ampere seconds squared per kilogram. Ampere seconds squared per kilogram. This makes our answer to be B. An aircraft heads in a direction at an angle theta east of north with a horizontal velocity relative to the air of 800 kilometers per hour. The wind blows with a horizontal velocity of 200 kilometers per hour from east to west, as shown in the figure, not to scale. The resultant velocity of the aircraft is in a direction due north. What is the angle theta and what is the magnitude of the resultant velocity? So they say the resultant velocity is in a direction due north. So the wind is blowing in this direction and an aircraft heads in a direction at an angle theta east of north. So the aircraft is moving east of north at an angle theta, and the resultant is due north, so the resultant is vertically upwards. So this one is 200 and this one is 800. So the question is, what is the angle theta and what is the magnitude of the resultant? Of course, for the resultant, I will just use Pythagoras theorem because one of the vectors is in the horizontal, the other one is in the vertical, so I'll use Pythagoras theorem. So I'll say the resultant is simply going to be 800 squared minus, it is 800 squared minus 200 squared under the square root. I think this font is very large. Okay, so let me find the square root. So root of 800 squared minus 200 squared. That gives us 774. So the magnitude is approximately 770 kilometers per hour. Then let's check the direction now, or the angle. So this is in the adjacent, the other one is in the hypotenuse. So from SOHCAHTOA, so we have adjacent, hypotenuse, that is cos. So we have that cos or theta is equal to the cos inverse of adjacent, which is 200 over 800. So 200 divided by 800, and the cos inverse of the answer. So what is the angle theta and what is the magnitude? Sorry, theta is from the vertical. So this, let me call this one alpha then. Alpha is 75, then theta is measured from the vertical. So theta is going to be, let this be alpha. So theta is going to be 90 minus alpha. So it is 90 minus 75. Is it 75.5? 90 minus 75.5. So this is going to be 90 minus the answer, which is 14.5. So this is 14.5 degrees. So the angle theta from the vertical is 14.5 degrees. So the most appropriate value here is going to be A. So our answer is going to be A. A cathode ray oscilloscope is used to display a sound wave of frequency 2000 Hz. The display of the CRO is shown. What is the time-based setting on the CRO? So for the time-based setting, of course, the length representing one cycle is 1, 2, 3, 4. Those are 4 centimeters. So the length representing one cycle is 4 centimeters on the time-based setting, or on the time-based axis. And we want the period. We want the time-based setting. So they gave us the frequency. So period is equal to 1 over 2000, and the frequency is equal to the length representing one cycle times the time-based setting. So that is L times the time-based setting X. So remember, this one here is seconds because it is the period. So 1 over 200 into 1000 is equal to L, which is 4 centimeters, times X. So I'll just divide 1 divided by 2000 divided by 4, which gives us 1.25 times 10 power negative 4. Remember, that is going to be seconds per centimeter. So X is equal to 1.25 times 10 power negative 4. This is going to be seconds per centimeter because I divided both sides by 4 centimeters, even this side by 4 centimeters. Now, the most appropriate answer, of course, is going to be A without even hesitation, because it is the only answer. These ones are extremely having different figures. So it is 125. You can try to bring in micro by dividing this by 10 power negative 6, because I said to bring in a prefix, you divide by its value. So this is X equals to 1.25 times 10 power negative 4 divided by 10 power negative 6. So divide this by 1 exponent negative 6. It gives us 125. So this is 125 microseconds per centimeter. Which row shows what all physical quantities must have? All physical quantities must have a unit. This one is showing there is no unit, so this row is out, B is out. All physical quantities must have magnitude. This one is showing they don't have magnitude, they don't have direction, they don't have magnitude, it should have magnitude. So we remain with two, A and C. Remain with A and C. And A is going to be out because some physical quantities are scalars, so the answer is going to be C, because they may not have direction, but they have the magnitude and the unit. What is an alternative way of expressing an energy of 43 joules? That is des. This D is des.